Hey Space Engineers, welcome back. In this video we're going to dive deeper into Mother Core and wire up a funky dance floor. If you haven't watched the first video of this series, I highly recommend it. It'll give you a crash course on setting up a new project and familiarizing you with how modules, commands, and events all work together to enable your automations. Okay, let's get back to it. Okay, let's do some cleanup first of all, so that we can get started on our dance floor. So firstly, I'm going to delete our example module, mostly because we don't need them anymore. I think we proved our point, and ultimately the party module rather is about partying, not greeting. So we'll make sure that we also remove him from our registration in our program. That way it's not causing any conflicts. And then let's clean up our message chain a little bit here. Okay, so ultimately the commands return strings to the player. The command is responsible for the sort of that final output to the player. I think in this case, actually, we probably don't need to send a message directly from the command because we are going to print it from the module itself. So we just return an empty string. To the player, this is going to be basically a new line. They're not going to notice it. So this is a good way to get around this requirement. But let's always make sure that you're returning some type of feedback to the player through a command in the cases where it makes sense. Also in start the party, so let's keep starting the party. I think that's a good way to usher the player and make sure that we know what's happening. We do emit our event. That's fantastic. I don't think we actually need to listen for our own event anymore. So what I'll do is I'll comment out that code, and we don't actually need to subscribe to it inside of the party module anymore. That might change, but at least for now, let's assume it's not necessary. And that should be it for our cleanup. Now let's run a quick build, and we'll test it in game just to make sure we are in good shape. There we are. Let's do a run, and we see that the dance floor has responded, and we have started the party. Okay, cool. So that is all we need to get started. Let's take a look at our dance floor and figure out how we're going to go about doing this. So I got us started over here. We're going to do this on a small grid just to save ourselves some space. So let's imagine that we've got a series of lights. Okay, we'll do a 3x3 to get started. I think this will change pretty quick. But first of all, let's get these guys into a quick little group. These guys are light panels. So they should be appearing 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. We're going to create a group, and let's just call these dance floor lights and save those guys. We will not show them in the terminal. We'll just access them via their group name now, right? So there we go. So we can probably reduce their intensity a bit. We'll reduce their fall off. We'll reduce their radius. Ultimately, we don't want them to be too bright, at least for now. We'll just keep them in place, doing some fun stuff. And that's all we need to get started. So Dancefloor Lights is going to be the group that we're using for the rest of this demo. And we're going to start doing some pretty funky stuff. So let's go and look a little bit more closely. What does a dance floor really look like? I'm thinking disco style, right? So imagine that each of the squares of the floor are changing colors, and they're changing those colors randomly. I think we can keep things at the same interval change for now, and just all of the lights changing to different colors on the dance floor in sequence would be a pretty nifty effect. So that's what we're going to shoot for, and we'll see how far we get. So let's jump back into Visual Studio and let's get some code laid out to solve this problem. Okay, so let's go into our dance floor module and let's think about what a dance floor kind of does to start up, right? If we think we're going to turn our lights on, we're going to need to initiate and do a bit of a catalog of the blocks that are on our dance floor, right? So there's a couple of things we could start with. What I want to do is actually placehold first a function that is just start dance floor. Oops, not dance party, dance floor. Hopefully the autocomplete doesn't get in front of us too much. And we actually won't do anything yet. I'll just put a placeholder in there, sort of as an empty method for us to target. And of course down here, this is where we'd want to call that, right? So we will just copy the name down here. We will call that method. It's a local instance method, so we don't need anything more. And what we'll do is we'll take that text out and we'll actually just put it inside of our start dance floor method, because ultimately it's responsible for starting our dance floor. The handle event method is only responsible for listening and doing something when the right event is listened for. So we can even trim that a bit. Cool. And let's think about again, let's get our lights and make sure that we have easy access to them using our block catalog. So we want to do this in our boot method, and I typically try and do this as one of the first items. And so we want to get our Dancefloor lights, Dancefloor light blocks, and we can do this using our block catalog. There's a couple ways to get access to it, but this is the one I prefer. So mother, we have access to mother already as a instance variable, so you'll notice our base module has it. We're going to access we're going to go get module, and we're going to access our block catalog, which is one of the core modules. And then we have access to that module. And what the block catalog gives us is get blocks by name, where it has in a type, and then we pass in the name we want to get. And we know in this case it's a group called Dancefloor lights. Okay, and the type of those lights, well, in this case, I believe they're just my lighting block. That's it. And what that does is calls it, but that doesn't assign it to anything. So let's actually create a variable to hold these lights. Okay, so let's create the very top of our class. Okay, so what is this going to be? Well, for simplicity's sake, let's just make this a list. And for now, we will make it a list of my lighting blocks. We'll just call this Dancefloor lights, and it's going to be a new list of blocks. It'll be an empty list to start with. That's okay. And then what we're going to do is actually just we'll give that a capital D. And we're going to assign that when we boot. That is to say, when the module boots, we are going to get the block catalog. Oops. Then we're going to call the getBlocksByName method on it. And that's going to give, it's going to assign all of the blocks in our Dancefloor to our Dancefloor lights object, or list rather. So now, I think probably something that we should do just to prove our point is let's list out these lights. Let's make sure and validate for ourselves that we were actually able to get all of the lights in this group in our boot. Okay, so what we can do is just right after that, we are going to, let's go Dancefloor lights for each. We're going to pass in the light. We're not going to do that though. We're going to call mother.print. And we're just going to print the name of that light. Okay, so hypothetically, when we boot, the Dancefloor module is going to boot, and we're going to see a list of, should be, we did 3 by 3, so it should be 9 lights. So let's take a look. Okay, let's jump over. We'll look into mother. Let's do a recompile with our new version. And we expect, there you go, you've seen it. So we see our list of 9 lights. It does disappear, but if I run recompile one more time, and actually we could have run boot in this instance, we'll see the lights. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So we have access to those lights, and we can do something with them on every cycle, every second. It really doesn't matter. So let's go back to our code now, and let's think about what we can do to make this a little more interesting. And by that I mean, let's add some color. Okay, so let's think about how we can actually make our lights change colors. What we want to do is, first we'll just demonstrate this in the run command. Now, of course, remember that this runs 6 times a second. This is not going to be a good use case for this, right? The lights are going to be flashing so fast that it's not really going to be fun for the player. This is more just a proof of concept. I'll show you how to use the clock in a second to slow things down, but for now, this will prove our point. So now that we have our Dancefloor lights, all we want to do is really cycle through each light, pick a random color, and then assign that color to the light. We can do that pretty easily, actually. So let's just encapsulate this inside of a for each loop. We could do it this way based on the autocomplete, but I actually really think this is janky. So instead, let's actually create an array of colors we want to be using. And I think quite simply, we can just let this be an array. So we'll call it an array. Oops, sorry. It is a color, an array of colors. We'll make it a constant. And that's just going to be based upon a bunch of the colors provided by VRage Math. This is what the programmable block has access to for colors. And there's a huge amount of colors here, guys. It doesn't make sense for me to map all of them. So you'd want to pick the ones that make the most sense, but there's a good number of them. You know, you got your aquamarines and your dark blues and your royal blues and your sky blues and it's quite an exhaustive list. So what we want to do is effectively select a random color out of this guy per light, and then set the color of that light. So we know that the color is going to be, it's going to be a random instance. The difference is here, we're going to get rid of this guy, and we're just going to create a new instance of random. And we're going to go next, and this is going to give us a color, basically a random item from this array. So it could be any one of these options. And then we are going to, on that light, simply set the color equal to that color. And now that I see it, why don't we skip ourselves a little bit of code, and let's just set the light color directly to that random color. Okay, so let's build it, and let's go see what happens. Okay, we are here. Let's go take a look. Aha, okay, very interesting. So something to observe. Firstly, they're all switching to the same color. So that's peculiar. But we are seeing the overall effect working, right? So there's a random color being selected, and everything is being set to that random instance. Let's improve this a little bit more. Okay, so I made a small error, classic, and of course this is why we test. But ultimately, what I needed to do was actually set a single random instance, and then just call the next method on it for every light. So what I was doing before was actually just setting the same instance of random, and therefore the lights weren't changing. But this will give us a randomization of which light is selected for each, or which color is selected for each light rather. So let's go take a look at what that looks like in the game. So come over here. We can now see the dance floor is moving. Once the cycle, it's switching. But of course, it's a bit fast. Let's slow it down a bit, and let's actually use the clock schedule method. And this is another way we can circumvent the run to give us something that's a little bit more tailor-made for our uses. So let's go back into VS Code. Like I said, we don't want to be doing this 6 times a second. What if we said half a second or even 1 second? Effectively, it becomes a configuration decision for us. The implementation is mostly the same. And again, up at the top, we'll do this in our boot method. So usually at the very end, I like to execute stuff that we're going to be running more frequently. And like I mentioned, the clock module can help us here. And we're going to use the same way we got the block catalog to access the clock, and we're going to schedule a light update. So what does that look like? Well, first of all, let's get our clock, get module. It's the clock module, and that has a schedule method on it. And what we're going to do is you'll notice that the schedule takes an action and it takes an interval. Okay, so this is essentially, this thing will run every time we hit an interval. It's actually backwards here. The action is first, and what I would just say this is update lights. And we want to do this every half a second. Okay? And then we're going to create a method for this right below it, and we will call this update lights. There we go, we see that. That's all incorrect. But update lights is really what we want to be doing. So all of this here in our run method, if we cut that out, we paste that up here, that's now update lights. And in fact, if we do this, that will give us the same implementation that we just had. The difference is now we're going to not use our run method, but instead we're going to use the schedule method, and we're going to run this using the clock system. Okay, so let's do a build, and let's go see what that looks like in the game at a half a second interval versus a 0.16 seconds. And there you go. A little bit more manageable. Now, that's cool and all, but that's a pretty measly dance floor. I think we can really make this bigger. So let's hack it apart, and let's blow this up and make it a bit more exciting. So we'll start with the fun part. Let's just create a bigger dance floor. And what I'm actually going to do is I'm going to use my mirror tools here. There we go. What if we made it, I won't go all the way to the edge because we do have collision issues. We'll see how this fares. This could be a little wacky, but otherwise it'll be pretty epic, and I think it'll be worth it. Okay, we'll just make sure these guys are in here. There we go. Okay, so of course that's an outrageous amount of lights. What I'm going to do is access this guy. So we'll have one panel missing, but again, that doesn't really matter. So if we go inset lights, light panels, panel. Wow. All of those guys are part of the dance floor lights. Remember these guys. So I'm going to copy that name so we can assign it to everybody. But really, essentially, we're just going to look up all of our light panels. And we're going to select all these guys. We're going to select the dance floor lights as well, and we're going to save everybody as dance floor lights so that now it looks like everybody should be a dance floor light. Doesn't look like anybody's in a dance floor light. Oh yeah, okay, there we go. And our hidden guys, let's make sure that they are also dance floor lights. And they are, you can see them here. Okay, so now all we need to do is run the update on mother. We will find mother party. We will run boot. And boom, we have a dance floor, people. And that's really just the start. Ultimately, mother is there to expose a lot of the tools we use to do this, but she remains relatively unopinionated with what you do with those. So I hope this is really helpful. I really actually enjoyed building this. This is the first time I've ever really built something kind of for you guys on the fly without a lot of setup. So I hope this is very informative, and I look forward to creating a bunch more content on how to use Mother Core to start enabling cool things like this that kind of exist as one-offs inside of your ships without learning how to, learn an entire programming language just to build. So stay tuned, guys. Plenty more to come. Take care.